Okay, hello guys. We're going to start by watching a quick demonstration about the law of conservation of mass, and I think it's a really great video here. So you see he's just going to mass two different beakers, and let's see if we can speed up the settings here. And so he is adding vinegar to the left side, and you see it weighs 28.9 grams. I think that's with the beakers. And then he's adding some baking soda. And check it out, it's 35.0 grams. So he does the reaction, vinegar and baking soda. Oh, it spills over. Okay, whatever. But that drop still stayed on the balance, okay? So, wait, the mass is decreasing here. So, is that matter being destroyed? Where's the mass going, guys? Well, hopefully you guys should be noticing that there's bubbles forming, right? So it's making CO2 gas. CO2 gas being formed, and that CO2 gas is the mass that is lost because the CO2 gas doesn't show up on the balance anymore. So that is actually a pretty cool thing, and we can actually find the mass of CO2 just by indirectly measuring the mass of those products, okay? Using what we call the law of conservation of mass. Now, in a chemical reaction, you have the reactant on the left and the products are on the right. So the mass of the reactants is going to be the same as the mass of the products. So the number of atoms of each element has to equal the number of atoms of each element on the right. The left and the right must be equal. That's just the law, and we can't create or destroy matter. So it is also shown here. Now in this thing, this is a closed container. So as the reaction happens, as we start the reaction, we end up getting a products of the reaction, maybe a different color, but you'll see that the mass is still the same. Okay. In a closed container, that's what we would have seen, but that original video was an open one. So now we have yes, just the law of matter, conservation of mass is matter cannot be created or destroyed. So what you'll see here in some math equations is you'll see that you have 50 grams plus some mass of oxygen yields 95 grams of water, right? So could you figure out the mass of oxygen? Of course, we know that the left side must equal the right side, so the mass of oxygen must be 45 grams, right? 50 plus 45 equals 95. So think of this thing in the middle as an equal sign. We move on. If you had four terms, that might get a little scarier, but remember, you've got the left side and the right side. The reactants have to equal the products. Well, the reactants are 200 grams, and so the right side is 125 plus something grams. So that must be 200 grams as well. So this guy, the zinc, must be 200 minus 125, right? Hopefully we're getting that math, and it's 75 grams. One more, we've got sulfur, and we don't know the mass of the iron, and it makes a mass of 83 grams of iron sulfide. That is a precursor to gunpowder, by the way. And so we get, on the left side, it's got to be 56 plus x equals 83. That's a way to think about it. So the left side must equal 83, so 83 minus 56 is going to be 27. All right. So just a couple of thinking examples here. When an iron nail rusts, it gets heavier in mass. Does the iron nail follow the law of conservation of mass? Justify your answer with some theory. Think about that for a second. Well, since the iron nail rusts, it gets heavier. Well, yes, it does follow the law. You must always follow the law. That's because the iron nail reacts with the oxygen in the air to make iron 3 oxide. You're seeing a different color here, so a chemical change must have happened. So we've got the mass of the iron, the mass of oxygen from the air will equal the mass of the rusty nail. So you will consume oxygen. So now here is a tricky one here. When you have 50 milliliters of isopropyl alcohol, which is 39.5 grams, is added to 50 milliliters of water, which is 50 grams, the mixture will have a volume of 98 milliliters. Crazy. 50 milliliters plus 50 milliliters should be 100, but what happens is the volume goes a little bit down. Volume is not conserved like mass is, okay? Now, the mass in grams of this mixture should be 89.5 grams, okay, because you're simply just adding the mass of the water and the mass of the alcohol. But volume is never conserved, well, not always conserved. So that's because you can squish atoms closer together. Remember, that empty space in there does not weigh anything. So it's kind of a crazy thing. So this is where we'll start balancing equations, and we'll move on from there. But that is a precursor to balancing equations.